Hi, this is Wendy, and welcome to my No Frills Java video series. I don't do any fancy video production or anything, so you might hear traffic in the background, or my cat meowing, or my next door neighbors fighting with each other, but whatever. When you're coding in the real world, you're hearing these and lots of other noises, so just suck it up and get used to it. I'm going to show you some Java stuff, and I really don't have the time or inclination to create fancy videos with animation and all that other production stuff. We're just going to learn and code with Java. Now, in this series of videos, I'm going to introduce you to the basics of regular expressions and how to use them in a Java program. In the first video, we learned the basics of regular expression syntax, and we wrote a few really basic expressions. In the second video, we learned how to use character classes to match ranges and sets of characters in your expressions. In the third video, you learned how to use quantifiers to specify how many of a set of characters you want to match. In this fourth video, we'll talk about escaping special characters and also how you can use meta characters as shortcuts for common expressions. In the fifth video, we'll learn how to create more advanced expressions by using capture groups, and in the sixth and seventh videos, I'll show you how to use regular expressions in a Java program. Now, when creating regular expressions, you might want to include special characters or symbols that are actually part of the regular expression syntax. And you've probably done this in several programming languages. I teach Java a lot of the time, and sometimes in Java, you have a string literal and you want to display a backslash, which is the escape character in Java. So you just escape the escape character so that you can display a backslash. Or in some format methods, we have the same problem with the percent sign. So we just escape the percent sign when we want to display an actual percent sign. In a regular expression, you might want to write a regular expression that matches the actual dollar sign, but as we learned in the last video, the dollar sign is actually a special anchor character that means end of string. So this kind of expression wouldn't work because, well, first we're putting it in the wrong spot. So this would actually generate an error. It wouldn't work. It's not going to match your string at all. So how would we actually add the dollar sign as an actual character that we want to match in our regular expression? So whenever you want to use a special character, you need to escape it, and we escape it using, surprise, surprise, the backslash, just like we do in a lot of other programming languages. So in regular expression syntax, these are the different characters that you'll need to escape, and some of these characters we've learned already, and some of them we're going to learn the period, for example, and we're going to learn the pipe symbol, and you already know about a lot of these brackets. We'll learn these round brackets in another video. So all of these things are different characters that are part of regular expression syntax. So whenever you use one of these expressions, you just escape it using the backslash. And yes, the backslash is also a special character. So that means if you want to display the backslash, you just put two backslashes. Now, if you're inside a character class, inside square brackets, you actually only have to escape the caret, because that's the exclude operator, the dash, because that means a range, and the closing square bracket, so that it, if you put the closing square bracket as part of your characters, it's going to think it's whatever, and the actual backslash character. You don't have to escape all of these characters if you're inside a character class. Inside character classes, you only have to escape these four, so that makes it a little bit handy. This isn't something that you probably find easy to memorize. I honestly have to look it up every single time I need to know. So let's do a quick little example. So in Java, we have a statement system.out.println that prints something to the screen. So let's say I want to write a regular expression that matches system.out.println foo. For example, when I'm giving my students a quiz on the computer using our quiz software, I can tell it to automatically grade the answer by giving it a regular expression. And if the student answer matches the regular expression, it marks it correct, which is really nice for me. So if I want to do a regular expression, I'll just type in the whole thing first. So system.out.println and then foo. Already we can see some crazy things happening. And then a semicolon. So if you look at the list of characters that we saw, I'm using the period, I'm using the round brackets, double quotes aren't in there, which is kind of nice. And so these are things I'm going to have to escape. So you can see, right, you can tell the colors are a little weird. So the period symbol, I have to escape with the backslash. And you'll notice when you do that, Now it says it matches an actual period. Before, it actually says something else. The dot is a shortcut that means any character except a new line. We're going to learn that in a few minutes. So when you escape it, now it means the actual period character. And I have to do the same thing to these round brackets as well. See, now it says it matches a bracket. Same thing here. There we go. So there's a regular expression that matches the system.out.println foo, and you'll notice that it finds exactly one match in my output. This one doesn't match because system has to be an uppercase letter. This one's missing all the periods. This one's just got way too many extra characters. I don't know what's up with that one. Or you can do one missing the semicolon, you know, whatever you like. If you've programmed in Java before, I'm sure you can think of lots of other wrong ones that you can give it. But there, so I just have to make sure I escape any of these special characters when I want to use them in a regular expression. So give this a try yourself. This is an expression I actually use a lot for something else. So write a regular expression that matches the file name index.htm or index.html. In the old days, file extensions had only 3 characters, so it's quite common to see the index file of a website be HTML instead of HTML. So you're going to match index or index.html or index.htm. Basically, the L is going to be optional with no extra characters before or after. So you're going to use your anchors, which means you're going to have to go into multi-line mode. And then write another one when you get that one working. Write a regular expression that matches the main method header in Java. So again, Java language. If you're familiar with Java, great. If not, that's okay. You're just typing characters. You're not actually writing Java code. So public static void main, there's some brackets, string, square brackets, args, bracket, braces. Oh goodness, there's a lot of stuff. So give those 2 exercises a try. Go ahead and pause the video, give them a try, write down your answers somewhere, and you can then check your answers when you resume the video. Okay, hopefully you had a chance to give that a try. And here is the solution to the first one. So again, I've gone into multi-line mode because I'm using the anchors, the starts with and the ends with. So I've got my index. Now the dot is a special character, so I have to escape it. HTML, and we learned this in a previous video, how to make the L optional. I use the question mark immediately after it, so it always applies to the immediately preceding token. So there's my index HTML, and it doesn't match any of the other indexes that I've added here. And then for the public static void main string args, that's a mouthful to type. There's several different items that you're going to have to escape. There we go. So all of the parentheses, the opening square bracket, remember it was kind of neat. You don't actually have to do the closing square bracket. If you look at your, there we go, at your list, it was only the opening square bracket. You only have to do the closing bracket if you're in a character class, not in the, if you're outside a character class. So that's kind of nice and convenient. And we had to, again, escape this bracket and the opening brace. Again, if you look at the example, we have the opening brace here, but the closing brace we don't have to worry about. So as funky as that is. Now, if you try to escape it anyways, it's not going to complain. It's not going to not work. It'll still work, right? But if you don't have to escape it, why bother? But it's not going to cause any problems if you accidentally escape a character that you don't need to. As long as it's not a special symbol, like if you need the dot and you escape it, well, then that would be a problem. But, you know, it doesn't matter if you accidentally escape the closing square bracket, that's okay. But there you go. You'll see, I could have come up with like a zillion wrong answers for this, but we at least want to see that it matches the good one. So there we go. Now, regular expressions also come with some really handy meta characters, which are just shortcuts for commonly used tokens. So, for example, and we might have seen this earlier, is the \D is a meta character that's a shortcut for 0 to 9. And if you recall, you can also say not a digit or exclude digits, just use an uppercase D. So lowercase d and uppercase d, you can use those instead of 0 to 9. It's just a few less characters to type, and it's a little bit easier to read as well. So if we try a couple of examples, I'm going to go back into not multi-line. What's the opposite of multi-line? Single line? I don't know. So if I type, for example, we had that one example from a while back like this that was exactly 3. Let me get rid of all these. exactly 3 digits. That was one of the first examples we did. So instead of saying 0 to 9, if it's easier for you to type really fast, you can do \D. It's the exact same thing. If I use an uppercase D, that's the equivalent of saying anything that's not exactly, or that's not a digit. So not 3 digits. So any 3 characters that are not digits. Again, notice it's capturing white space and enter and all that kind of stuff. So any 3 characters together that are not digits, it will capture. Again, this is kind of review, but kind of not because the characters are new. So there's shortcuts for that. Also, word characters. We haven't talked about word characters, but there's a W, lowercase or uppercase. A word character is any character that's a lower or uppercase letter, a digit, and the underscore character. Those are all classified as word characters. And the reason why we have a shortcut for word characters is that classification or set of characters, letters, digits, and the underscore, they are often used to match file names, email addresses, URLs, and lots of other things. So rather than constantly typing upper lowercase letter, digit, and underscore, they just made a shortcut for it. So \W is the shortcut, lowercase w is a shortcut for any word character, and then uppercase is anything that is not a word character. So if we pop back over here and change our D to a lowercase w, you'll see it's matching any 3, and if you don't like 3, you can use a different number, any 3 characters that are word characters. I don't see any underscores with letters yet, but there might be in some of these other examples. Or you can just type some in if you want to try it out. So we can type in a few digits and letters we got, but we don't see underscore very often. See? And then I'll do another one. There, so we've got some underscores in there. So any word character, and then if you do an uppercase W, of course, that's the equivalent of not, right? So it's like putting the square bracket, I'll just type it in. So it's the equivalent of doing not, and then, oh God, I had to do that. A to Z, whoops, A to Z, A to Z, 0 to 9, and then underscore. See, whoops. You can see how using the \W is just so much nicer than typing all that crap. And we don't need this guy. So \uppercase W is the exact same thing. So any 3 items that are not word characters, which there isn't much here. Most of these things are word characters. So that's kind of a nice one. Okay, give this exercise a try and see if you can practice with word characters. So create a regular expression that matches an email address that consists of 4 or more word characters followed by @cattrees.ca. There should be no extra characters before or after the email address, so you're going to use your anchors, your start with and your ends with, and you're going to use the multi-line mode when you test it out. And I've given you some samples to try that are valid and some samples that are invalid, and maybe I would add another one of these that had an underscore character just to make it interesting. So go ahead and give that a try. When you're done, you can just resume the video and then check your answer. Okay, so hopefully you had a chance to give that exercise a try. So I'm in multi-line mode. I'm going to put my anchors in there. So it was 4 or more word characters. So \W and then 4 comma. So 4 or more word characters. There's my 4 comma quantifier, followed by the @ symbol is not a special character, so we don't have to escape it. Cattrees. .ca, but the dot is a special character. We're going to see that one in a few seconds. So I do have to escape the dot. There we go. So that matches. I added a couple extra here to play with, but that matches all of these. So that matches all of my valid email addresses. It doesn't match these two because they have an extra symbol in there. Now we keep seeing the dot popping up in some of our conversations. So the dot or the period or the decimal is another meta character. It doesn't use a \. And this one will match anything except the new line character, which means pretty much anything. So it'll match any character that is not a new line character. So for example, let me get rid of some of this stuff. Let's say I want to find any single character except new line followed by the letter D. Nice and basic. So there's a C followed by the letter D, a space followed by the letter D, an @ symbol followed by the letter D, an actual dot followed by the letter D. So this dot symbol is, and it says right there, any character except line breaks, except the new line. So that comes in handy when you're testing for things like names or addresses, because addresses are pretty much any character except for the new line, right? Or passwords. Passwords is a common one. We use it a lot for testing passwords because there's symbols and all kinds of other stuff in there. So that's a nice one. And then another meta character that we like to use is the whitespace. So \S is any whitespace character. A whitespace character is any space, tab, or new line. So anything that creates whitespace, basically. And if you want to match anything that's not a whitespace, then you can use the uppercase S. I think I mentioned whitespace back when we did the postal code exercise, so an alternative is to use the \S instead of just the space bar. But then the issue with that is that it would, if somebody put letter, number, tab, number, letter, number, that would be valid, and that would be really hard to input in a program. But hey, I'm going to turn off my multi-line here for a second. And we're going to try out a new one. So let's say I want to find any, whoops, I don't want to type down there, any lowercase letter. I don't know why I keep typing that. There we go. Any lowercase letter followed by any white space. So we can see a lot right here. There's lots of white space here. And what's really interesting is, I'm just going to paste some stuff in here to test it with. There we go. So any single lowercase letter followed by any white space. So the ones that are followed by a space are pretty self-explanatory. This, and again, I know it's there. I don't know how well you can see it in the video. A tab shows up as sort of like a dotted line with an arrowhead at the end. So that's a tab. So you can see the A and the big tab at the end there that it's capturing. See the range, 23 to 24. It's only two characters, the A and the tab. The tab itself is a single character, and it's the A at the end. And that's because there's a new line at the end. So what new line is a white space. So that's why it's capturing all the stuff at the end that's a lowercase letter, because there's a new line character at the end. It doesn't capture this because it's a number and it's not a letter. So you can see there, it's capturing any lowercase letter with either a space, a tab, or a new line immediately after it. So that's kind of a neat one. I use the space one a lot too. Now, as we said before, you can use uppercase S for anything that is not a white space character. So again, this one, it's capturing anything that's a letter followed by a non-white space, which basically means a lowercase letter followed by almost anything, because anything that's not a white space, right, is pretty much any other character. So that's kind of a neat one. So you can use either one of those. Now this last thing isn't actually a meta character, but it kind of fits, so we'll just talk about it now, and that's the OR operator. So you can use the OR operator in your regular expression. So for example, you might want to write a pattern where you might want to say, match a digit followed by a letter, or a letter followed by a digit, and you can't do two regular expressions, at least not easily. So this is where an OR operator would come in handy. So we use the pipe or vertical line symbol on your keyboard. So I might want to match like any digit or any one of these symbols, and I'm only going to pick some of the symbols. Just copying and pasting here. Notice that the caret, I had to escape it. I did a version of this earlier without the caret because we hadn't learned escaping yet. So notice I did it this time and it's got a caret. So this will match any single digit or any one of these characters. And so we can see obviously digits and individual characters are all highlighted as matches. So it's matching any single digit or any single one of these characters. So that's where an OR is really cool. Now you want to be careful with the OR operator and how it works. If you had an expression like this one, this means I am matching 2 digits followed by a letter or 4 digits. It's not saying 2 digits that might be followed by either a letter or 4 digits. I don't know if that makes any sense. So it's this whole part of the expression on one side of the OR and this whole expression on the other side. If you wanted to say 2 digits and then those 2 digits might be followed by a letter or those 2 digits might be followed by 4 more digits. You'd have to write that differently using capture groups, and we're going to cover that in the next video. But for this, it's this whole pattern or that whole pattern. So that's something you want to watch out for when you're using the OR operator. Now, it probably makes sense that you don't need an AND operator, because what are you going to do? Say that a character needs to be both 2 digits and 2 letters? Like, that's impossible. So there is no AND operator, in case you're curious. It's just not necessary. So try this exercise. Write a regular expression that matches either 4 digits or 4 uppercase letters, and your expression should match A, B, C, D in all uppercase or the numbers 1, 2, 3, but it shouldn't match any of the following examples that you see here on this screen. So you can grab all those or type them into your tester and make sure they don't match your regular expression. We only want to match either 4 digits or 4 uppercase letters. Now this one might be a bit tricky, so keep trying different things until you get it working. So this one's going to take a bit longer probably than the other ones. Be sure to use the regex tester tools. In earlier videos I showed you how to do things like find the explain tab or option that explains what your regex is doing, so make sure you take advantage of that. Go ahead and pause the video, try this exercise, record your answer somewhere, and then when you're done, resume the video and we will take up the solution. Okay, so hopefully you had a chance to give that a try and troubleshoot it a little bit. I'm going to take you through step by step, just with a thought process that a lot of people generally do. So because we're concerned with there being only these 4 things or these 4 things, we're going to stay with, are we in multi-line mode? No, we're not. We're going to go into multi-line mode and we're going to use the anchor. As you probably figured out, you definitely need to have the anchors in this exercise based on what we're required to do, right? So these things shouldn't match. For example, these shouldn't match because there's other stuff in there. We only want exactly 4 digits or exactly 4 uppercase letters with nothing else around them. So you might be thinking, yeah, okay, I know how to do this. Uppercase letters, or digits. I don't know why I chose to do letters first. It doesn't matter if you did letters first or digits first, honestly, because that's how ORs work. It's all good. So you think, okay, I want uppercase letter or uppercase digit or digit, and you think 4 of those, right? You probably already know this is wrong. So if I do it this way, remember that quantifiers only apply to the thing immediately to the left. So this means a letter or exactly 4 digits. So right away you think, oh, that's not right. You see, because it does match the first one, but then only 1A, right? Because it says 1 letter or exactly 4 digits. So we're going to have to say either 4 of these or 4 of those. So you're like, okay, cool. Now I got it, right? Nope. So we've got exactly 4 letters, uppercase letters, or exactly 4 digits. So you're like, yay, these are selected, but these are selected and these are selected. And then these are both selected. It selected both the letters and the numbers. Like, what the heck is going on? So you're thinking, did I put my boundaries in? Because this tells you right away, like, oh, you didn't put the boundaries in, right? Whenever you see the extra stuff, like these 2 examples particularly, think, oh, I didn't put my boundaries in, but look, my boundaries are there. But remember how the OR operator works. The OR operator says either this whole thing or this whole thing. You see what I did there? So on this side, we're saying starts with 4 uppercase letters, or it ends with 4 digits. That's what we've done. So that's why this one matches, because it starts with uppercase letters. This one matches because it ends with 4 digits, right? And so same thing, these ones don't match because this starts with 4 digits. It doesn't start with 4 letters. And this one ends with 4 letters. It doesn't end with 4 digits. These ones match, but there's 2 matches. Let me scroll this so that the pop-up comes down here. See, this one matches because it ends with 4 digits. This matches because it begins with 4 letters. Ends with 4 digits. So that's because this whole thing is one side of the OR, including the starts with. And this whole thing is the other side of the OR, including the ends with. So to fix it, Yes, you have to put the starts with and ends with on both sides. Now we have what we want. We only wanted the first two to match and none of these. Hooray, it's actually working. You've learned quite a bit about regex so far, so take a few minutes to think about how you might create a regex for a floating point number or a decimal number. Now, in most languages, any of these values that you see here would be considered a valid floating point or decimal number. You can see there are regular decimal numbers, including values like 0.0 and 0.0, as well as other decimal numbers that have digits to the right of the decimal point, but not to the left. And of course, integers should match as well. And we could also allow for an optional positive or negative sign, as you see in these last examples. Now, in general, values that consist of one or more digits to the left of the decimal point, but no digits after the decimal point would be considered invalid, such as this one and this one. And of course, just a decimal point all by itself would not be valid either. These values would not be understood by most programming languages as a decimal value, which is kind of odd. We, as humans, can probably imagine this would be the equivalent of 2.0, and this would be the equivalent of 1122.0, but a lot of programming languages don't see it that way. They definitely wouldn't understand a decimal point all by itself, but we also don't want to allow any values that have more than one decimal point, since these clearly are not valid values either. So this is a tricky example, and it'll take some time to play around with and try different things, but it's also a very basic example. You might also want to, in the future, consider values like 2 followed by a decimal point, or any number of digits followed by a decimal point. Again, you might want your application to translate those as 2.0 or 1122.0, but to get that to work, so to make these two values here valid in your regex, that would require something called capture groups. Capture groups allow you to create even more complex regular expressions by grouping the tokens together. So you can say things like these tokens or those tokens, and you can even grab the matching values that those tokens match and use them later in the expression, which I know sounds a little weird. It's going to be easier to understand with an example, and I'm going to cover that with lots of examples in the next video. So until then, thanks for watching.